Hello everyone and welcome to today's webinar on Blueback Geodata Investigator version 2.1. This is an advanced data analysis plugin for Patrol, and we're going to focus on some modeling and RE-based workflows in GDI. My name is Mark O'Brien. Thank you for your participation. So just a quick note on how to participate today. We're using a GoToMeeting hosted presentation. You should see a little dialogue like this. You can open and close the panel via the little red arrow. You can choose to view the presentation as a full screen or window via the view menu. By default, everyone is muted, so please submit any questions you have into the text dialogue, and I'll break them out at the end of the session and work through them. The webinar is being recorded. A link will be provided within 24 hours. Please feel free to distribute as you require. The recording will also be uploaded to our website as well. So the agenda for today, I'm going to work through a quick introduction to Geodata Investigator, which I'll refer to for the main part as GDI. So an introduction to the plugin in PowerPoint, then spend the majority of the session in a live demo. Starting off in GDI, working through the investigations and the windows, working some trend analysis and data classification on our well data, then running a few modeling-based workflows, for example, sampling seismic into a grid and QCing in GDI, cross-plotting seismic and well data, running some QC on your upscaling, so cross-plotting wells, raw well data, upscaled cells, grid models and simulation data all together. Also working some volumetric analysis, and then it's going to jump into briefly into another plugin, the Toolbox, to show some of the modeling and RE tools we have in there. So quickly work through another upscaling QC workflow we have in the Geology Toolbox, show you the water saturation modeling, pressure gradient analysis, and also the well test plugin, or the enhancements to the well test plugin that resides in the Reservoir Engineering Toolbox. I guess we'll then sort of take a summary at the end and answer some of the Q&A that have come in, also talk about licensing and evaluations. So on with the introduction. So GDI is essentially a powerful cross-domain data analysis plugin for Patrol. It separates out data selection from data visualization by the means of a GDI investigation. So this means you sort of load or pre-process some data to an investigation. Then you can share that investigation between multiple windows. GDI allows you to analyze cross-domain data in the same space. So this means you can plot 2D, 3D seismic data, grid models, surface attributes, table data, point sets with attribute. They can all be analyzed in the same space. GDI also introduces 5 new custom windows. So we have a new histogram, a scatter plot, a cross plot, a matrix plot, and a parallel coordinate plot. So as I mentioned, GDI is sort of powered by an investigation. So this means you can essentially load multiple data types with matching templates to an investigation. And then once that sort of load is done, you can share the investigation between multiple windows. GDI allows you to store multiple investigations, so you can set these up and store them and kind of come back to them. You can load up to 20 different dimensions into an investigation. Spatial dimensions can also be allowed, so you can plot, porosity versus time or depth or X or Y. And there's a whole bunch of settings which we'll come to in the demo that are managed through the investigation panel. So once you've loaded your data to an investigation, there's 5 new windows. So we have a scatter plot. So this is a basic 2D kind of data analysis window with a rich selection of filters, classification, workflows, equations, annotations, visualization tools. Lots of integration with data selection within one of these plot windows and native Patrol space. The new histogram window. So this is a much kind of richer histogram window than you get in Patrol. Allows you to display your data as individual or stacked bars. Various filtering options, statistics are available, cumulative distribution functions, lots of export options, etc. The crossplot, so this combines the scatter plot and the histogram we've seen previously. So there's 3 kind of viewports. The scatter plot and then on the X and Y axis we also have a histogram. The matrix plot, so this allows you to plot multiple dimensions against one another for a quick multivariate analysis. So here you can see I've loaded 3 seismic volumes, so you can plot each seismic volume against each other, to allow for a quick kind of initial AVO screening. Here I have some acoustic impedance density, S-velocity logs, well logs that have been loaded again. You can plot each dimension against each other and quickly kind of make a trend analysis. The parallel coordinates window, so this is a common way of visualizing high dimensional geometry and analyzing multivariate data. Here I have porosity permeability gamma, colored by fasces, so you can use to QC your fasces classifications, for example. As I mentioned, GDI has a lot of integration with a native patrol space. So what I mean by that is by representing your data selections in a particular GDI window, or you can represent your data selection in native patrol space. So here I have a seismic crossplot. I've made a filter on some low values here. I can then represent those as a dynamic point set in patrol. So as I move the filter, the point set updates in the 3D window. Similar things for grid filters. So I have some grid data plotted here. I can filter and update the 3D. Dynamically update the 3D parameter in 3D window. You can also create classifications. So here I have porosity permeability crossplot. I've made a selection and applied a discrete code to each selection, and from that I can create a fasces log, for example. Okay, so let's jump into Patrol and have a look at the tool. So as I mentioned, GDI works by creating these investigations. So the way that works is you come to Insert, New Blueback GDI Investigation. This will open to the investigation panel to the Data tab. You can then start to load all of these data types. So for example, model, seismic, well data can all be brought into the same space. You can add, a number of continuous dimensions, or discrete dimensions, or X and Y and depth, etc. So I'm just going to open up some pre-populated investigations. So this is the investigation that's feeding into this window here. So here you can see I have just one well loaded with porosity permeability gamma and a couple of fasces logs. This next investigation, I have some seismic data loaded. So I have 3 seismic volumes loaded to the investigation. So the investigation also acts as a central repository for any kind of selections, equations, or annotations you've made. Okay, so there's some selections. Equation settings can be managed, annotations or classification groups if you have them. So once you've created these investigations, you come to Window, and then you have the 5 new plot windows. So histogram, scatterplot, crossplot, matrix plot, parallel coordinates plot. So what we have here is a crossplot. So this is a crossplot of our porosity permeability from our B2 well. So lots of everything's kind of synchronized for zooming and panning. There's tools for choosing which dimension you want to display on each axis. Tools for controlling data visibility, how the data is colored. All the filtering, so a selection of GDI and patrol filters, classified regions, which we'll touch on later in the demo. All of the dynamic and static equations. So a very rich selection of data analysis functionality. So that was the crossplot. The next window is the Blueback histogram. So we'll look at this example later in the demo, but this is a set of seismic data I've sampled into our modeling grid to use as a conditioning variable. So we can display as stacked bars or individual bars, as lines or bars, again stacked bars, as lines or bars. So we have our cumulative distribution functions laid on top, and we also have the statistics available at the bottom. The next type of window is our matrix plot. So this is, again, that cross plot of 3 different seismic volumes, so nears, mids and fars plotted against each other. So they can use this, for example, as a quick AVO screening. So I can select some of these anomalous data down here. The same data gets selected in each of the corresponding viewports in the matrix plot. Another quick example of the matrix plot here is the same plot we were looking at before. So this was porosity, permeability, gamma plotted against each other for that particular well. Again, you can make quite a broad visualization for any trends that are in the data. The fourth window is the parallel coordinates window. So again, for that particular well, I have each corresponding sample from the well, so is tied together with a line. So we have porosity, permeability, gamma, vertical axes. These can be sort of swapped around and shifted and scaled. And in this example, I'm using it to QC my fascies classifications. The last window is a scatter plot. So this is just a 2D analysis of data. In this case, I have some S velocity versus PS velocity ratio overlaid with a standard rock physics model. So what we're going to do is come back to this window. We're basically going to rebuild this investigation and rebuild this window to kind of show you how the workflow goes. So what I'm going to go to Insert GDI Investigation. I'm going to select a well folder, in this case my C wells. I'm going to add 3 continuous dimensions. That's going to be porosity, permeability, and gamma. I'm also going to add a discrete fluvial fascies. So you click OK to load that data or index that data to the investigation. Come to Window, take a new crossplot. So that investigation was added to the bottom of the folder here. So we just turn on. So we start off with porosity against permeability for all of our well data. So we can choose to color this by fascies, for example. We can choose to drop, oops, sorry, I meant to add another well. So I can come back into the panel. So I have my well folder. I can also choose to add an individual well. So I can take my B2 well. So it picks up the logs. There's obviously 2 porosity logs here. So click OK. So what I'm going to do is to deselect the C wells that we have. Click to view all. And then we can start to add in the equations based on these clouds of data. Just make this a bit bigger. So to do that, we come into the filters and we'll take a freehand filter. We can select this cloud of data here and then choose to add a static equation, which is going to be an exponential line through there. We take that filter off, add a new filter. Yep, take this kind of cloud of data. Again, add a static exponential line through that, and just choose to not display the selection. Okay, so if we come into our equation settings, we can choose how both those lines are displayed. So, for example, we can make them black, show the equation on the line, show the errors in red based on a certain confidence factor. Okay, so we have our relationships for these 2 clouds of data. We can also choose to, from the context menu for that particular data type, choose to show as a point density a background plot. And then from the axis settings, we can increase the resolution, for example, on the binning to get a finer resolution on the density plot in the background. Oh yeah, it's also possible to take the point size down from the context menu such that it doesn't obscure so much the background density plot. Okay, so we're going to use this data to run a classification workflow next. So I'm just going to turn off the equations and lose the point density and make the point size larger again, and choose to color by gamma in this example. So also under the selections, we used the filters previously, we can run a classified region. So we're going to take a freehand classified region. Again, select that data. From this classification selection, we could right click, come into the classification group settings, choose to add a new classification group, which in this case is going to be a set of discrete fasces codes. And then now I can right click again on that classification, assign a classification which is going to be carbonate, for example, add a new freehand classification to these data. Same thing, right click, assign classification, whatever, coarse sand, and the last one, shell, for example. Okay, so it then becomes possible, now you've assigned the classifications to, color the data by classification group. And then also again from the context menu for that particular well, we can right click and save as a classification well log. So this is the corresponding well here, and if I come to my well logs, okay, so we have our porosity gamma logs, and then a new classified log, or fasces log in this case, based on the classifications we've made here in the crossplot. So as I mentioned, it's also possible to bring spatial dimensions into an investigation. So if I open this investigation and come to the data tab and choose to add a depth, for example, I'm just going to take a new scatter plot, turn on that investigation. Let's just look at B2, and we'll set our y-axis. Didn't pick up my depth. Okay, so you can set the plot, in this case, for example, porosity versus depth. One last thing to show you before we move on slightly is if I choose to display my seawells, and we'll take a porosity gamma plot. So we'll make the X gamma, like permeability gamma plot colored by porosity, for example. What I'm going to do now is to create a point set based on my selection in the plot. So I'm going to add a rectangle filter, select some of these data here. We'll just make this a bit darker so we can see it. So I've selected some data points. I'm going to toggle here to create a dynamic point set and open a 3D window, put it next to this selection. So here I have the well data that's involved in this particular plot. So if I come to the bottom of my input tree, I can turn on my dynamic point set, choose to let's make these black, for example. So as I move the filter around now in the plot, you'll see the dynamic point set representing the data selection within this particular filter update dynamically in 3D space. So as you can see, we've run some very nice trend analysis, created data classifications, shown how we can dynamically integrate our well data analysis with Patrol Space. So next I'd like to show you the utilize the same investigation in a matrix plot window. Again, so some more analysis on our well data. So I'm going to open a matrix plot and turn on the same investigation. So we'll just tidy this up a little bit. With a matrix plot, you can choose which dimensions you want to display. So I'm going to drop the depth. I'm also just going to bring this back to our B2 well, color by fasces, and click to view all. So you can see we have these crosshairs kind of tying the cursor position between each window. And also if we add a filter, so add a rectangle filter and make a selection data here, the same data selection is applied into each in each viewport. So it's possible to double click on any of these matrix plot windows, maximize the view, and also just to show you any filter you have applied in a particular GDI window can be shared between other windows. So what I'm going to do is open a Blueback Histogram window, turn on the same investigation, again color this by fasces and make the same selection of data. If I come to my control selections, you can see this filter is available for selection. If you apply the filter in a histogram and toggle statistics, you get two sets of statistics. So you get filtered and unfiltered. So the top 5 here are my unfiltered and the bottom 5 are my filtered. So you can see, these are dynamically linked, so I can change my filtered selection within the particular crossplot, have that linked into a histogram and see what effect that selection has on my statistics. Okay, so moving on to the next workflow, which is going to be QCing the sampling of seismic into a grid, if you wanted to use a conditioning variable, for example. So here I have a sweetness seismic volume, which I've sampled into my modeling grid by various different algorithms. So I have a predefined investigation, this one, seismic resampling. So this is composed of my original seismic, I've got my original seismic sweetness volume, and then 3 different versions of the scaling into the grid run by intersecting RMS, intersecting harmonic and closest sampling methods. So we can QC these by taking a histogram, turn on my seismic sampling. We'll choose to set this as individual bars and importantly as a volume weighted display. Add in a legend, so you can see that the red distribution is my original seismic sweetness attribute. And then we have the 3 different upscaling methods, so closest, intersecting and intersecting RMS displayed in various blues. We can turn on the statistics to see the min, max, median, standard deviation for each of the upscaling method compared to the original data. We have our cumulative distribution functions, which we can choose which percentile we want to have displayed. So yeah, you can see there's a sort of rich context menu from within a viewport. So tools for exporting data selections to spreadsheets or pointsets. Again, all the options for how you want the particular histogram displayed as individual bars, stacked bars, or bars or lines, for example. So now that we've got this, we've sampled this seismic volume into the grid, it becomes possible to cross-plot an attribute versus a well log or upscaled well log, for example, to see what relationships there are, such that seismic can be used as a conditioning variable, for example. So I'm just opening some windows here and just sort these out. So what we have here is our sweetness attribute and some porosity logs, both of which have been upscaled into the modeling grid, and these upscaled or these cellular values are cross-plotted here. So what we can do, for example, is to start to look in a particular fasces. So for example, our channel fasces, what kind of relationship is there between the sweetness attribute and porosity? So again, we can add in a static linear line in this case. Okay, and then we can Also, for example, for our background, again, display that data and again apply a static linear line. Okay, so we've sampled the seismic integrator. We're just finding those relationships by facies between porosity logs and seismic attribute, for example. Okay, so GDI also allows us to run a full QC across the complete well model and simulation workflow or data sets to see that the data distributions and trends are honored. So I have a pre-built investigation here called Upscaling QC. So there's 4 different data types in here. The first one is my raw well data for porosity permeability facies. The next one is my geogrid upscaled. So here you can see I've toggled upscaled only. So this is my porosity permeability facies upscale data. The next one is my geogrid propagated data. So this is my modeled parameter. And the 4th data type is the simulation grid. So again, the cellular values that have been upscaled from the geogrid into the sim grid. So again, we can take a new histogram, turn on our upscaling QC. So add in a legend so we can see what we're looking at. And we'll choose to display as individual bars. Again, importantly, as a weighted percentage. Turn on our statistics. So you can see the black is our raw well data porosity distribution. Then we have the upscaled cell in grey, the model parameter in sort of light purple, and the simulation grid in dark blue. Again, the cumulative distribution functions are overlaid, so you can say, perhaps there's been a bit of a loss during the scaling of your raw well data. It's also possible to QC for any of the other parameters, so we can quickly swap to a permeability distribution. So you can see we've lost some of this low permeability from the well data, which has been lost through the modeling processes and upscaling to the simulation grid. So all of these properties were loaded with the zone and segment filters available. So it's possible to filter your sim grids data by segment or zone. Turn on the corresponding well that sits in that particular segment. So break down this analysis by segment, zone, etc. Okay, so just a little bit more on the integration between data selection in a GDI window and native patrol space. So I have here, again, this is our modeled porosity permeability versus the upscaled simulation porosity permeability for 2 particular zones. So this is one zone and another cluster of data here from another zone. So it becomes possible. We also have the corresponding permeability parameter here in the simulation grid displayed in the 3D window. So with a Petrel filter, so we come to filters, add filter, 1D Petrel filter. Make a selection of data. We'll color this by permeability actually. If I toggle on the 3D window and come to my Petrel filter folder, so I can turn on this 1D filter in the 3D window and then dynamically update the filter on the cellular model by shifting the filter around in GDI here. Okay, so just another example of how you can sort of integrate your data selection within a GDI window with native patrol space. Okay, so one last example in GDI before we just jump into the toolbox quickly is some volumetrics QC. So here I have an investigation called Volumetrics. which has various stochastic realizations for STOIP, GIP, and the corresponding fasces parameter loaded for 5 different realizations in this case. So you can see for each grid I have STOIP and GIP fasces, and in this case the zone filter turned on. So it becomes possible to, in this case, plot your STOIP distribution. I've combined it here with some volume height maps that have been created from the particular volumetric parameters. So here we can see 3 different STOIP maps and various stochastic distributions. Again, you can sort of turn on the statistics for these particular histograms, and also display the particular distribution from a particular realization for a particular zone in this case. I also have a similar example for it's the same feeding from the same investigation, just doing a similar thing for GIP, stochastic GIP realizations. Okay, so that was it for GDI. What I'm just going to do now quickly is to jump into the toolbox to show you some of the sort of modeling and RE tools that are available in the toolbox. I'm just going to jump projects quickly. So we're going to work through another kind of upscaling QC tool, look at the water saturation modeling, pressure gradient analysis, and quickly the well test tool that's available in the Reservoir Engineering Toolbox. Okay, so the toolbox, if you're not familiar with it, lives here under Blueback Home. So I can click the drop down, come to Blueback Toolbox. So the toolbox is basically a set of kind of domain tools that aren't available in Standard Patrol. We have a geophysics toolbox with various kind of advanced seismic analysis tools, geology toolbox for kind of modeling and QC workflows. Reservoir Engineering Toolbox includes pressure gradient analysis, which we're going to look at, and a project management toolbox for kind of keeping your projects neat and tidy and helping import exports. But we're just going to quickly touch on 4 tools. The first one is the Upscaled Log QC. So this tool allows you to QC the upscaling. So it basically makes a calculation per well by zone of like hydrocarbon pore volume, porosity, permeability, water saturation averages, etc. between your raw and upscale data. So the way it works is to select a set of multiple wells, select your tops, a reservoir flag, so porosity, water saturation and permeability from your raw data, pick a grid to which you run the upscaling, input your net to gross, porosity, water saturation and permeability again. Just click OK to run the tool. So this opens up a quick calculation QC panel. So it's run for all of the wells. So we're currently looking at C2 well in this case. So the first part of the panel is the log sum and averages. So for each zone I have my tops, my gross thickness, net thickness, porosity, hydrocarbon pore volume, permeability thicknesses, and then porosity average and permeability average for this particular well in this particular zone. We then have the upscaled calculation. So here I can see my porosity average in my well for this zone was 0.037, and in my upscaled it's 0.024, so it's obviously not gone very well. The next part of the table down, so if I follow this down, gives me the difference. So the difference between my raw and my upscaled is 0.012. And then it lastly shows that as a percentage, so it's 33% out. There's a 33% difference between my raw porosity and upscale porosity. So similar calculations for water saturation and permeability. So this table can be exported for Excel if you want to kind of take it out for reporting purposes, for example. The next tool to show you quickly is the water saturation modeling. So this lives in the geology and the reservoir engineering toolboxes. So it says it's a process tool. So what I need to do is come to the processes, open the water saturation process. So this is basically a J function calculator. So it basically wants you to input your porosity, permeability and water saturation from your raw well data. It then allows you to play around with the settings for a J function. In this case, they're nested by fasces. You can also nest them by zone and segment if you have different contact regimes. So for example, if I toggle off auto fit, so I can start to fit my J function here to the cluster of data I have here. So we'll quickly add in the one that's missing, which is our background fasces. So we'll just color the J function accordingly, gray to match, add in our water contact. You can play around with the irreducible water saturation, maximum water saturation, and if I take off my auto fit, so this is going to be 170, and this is going to be -4. Okay, so we've kind of fitted the J function to the background data here. So once you have these relationships in place, you kind of upscale those J functions essentially. So use them against your porosity and permeability grid parameters and output a water saturation parameter, a calculated water saturation parameter. Again, this kind of takes into account realization, so you can run this against each kind of realization you have from a stochastic run. Okay, so that was a couple of sort of modeling tools. The last two tools quickly are reservoir engineering based. So again, I'm going to open the toolbox, come into my reservoir engineering toolbox and choose my pressure gradient analysis. So this is a tool which allows you to run pressure gradient analysis. The way it works is to load pressure data. So here I have a set of a pressure file, so formatted well depth, pressure type, tool type, and quality. You just use this ASCII loader to bring the data in. So that displays as a set of points here in this plot. In the background we have a set of guidelines. So we have our hydrostatic, lithostatic, fracture and mud gradients, which can be, the gradients can be edited via the settings. The process is then to add in a gradient line folder, which is this thing. Again, I can double click this in and set the minimum and maximum gradients for oil, water, gas. It's then possible to filter the data by any of the attributes that we've brought in. So for example, we have some unknown quality or poor quality pressure data from, there's a tool failure perhaps, for example. We can filter those out of the plot. So the next thing to do is start to auto-fit the gradients. So the way that works is to set points inactive. So I can choose to use this rubber to essentially deactivate these points. Just make a bit of a bigger rubber. So I've kind of isolated my gas gradient, and then you click here to create a new line based on the active points. I then quickly invert those and choose to deactivate my oil, what I think is my oil gradient. Again, just click to auto fit a best fit gradient to the water points. Again, we'll just swap these round and take out the gas points. So again, we'll fit a line, auto fit those lines. If I toggle off clip, okay, so we can turn on the three lines that we created. Just need to extend this one a little bit. Oops. Going to move. Okay, that'll do. Just to create the intersection. Then we create clip. So based on the intersection, it's going to auto calculate the contacts. You can come into the gradient line settings, come to the statistics, and read off where it's calculated the oil, water, gas contacts, plus or minus a certain uncertainty. So you go, just to show you it's possible to work your pressure gradient analysis in Patrol without necessarily taking the data out. The last tool I'm going to show you is the well test tool. So this is what's called the well test and simulation QC plugin, or workflow essentially. It basically allows simulation pressure to be compared directly to observed pressure and pressure derivatives or deconvolution data for well test operations. So doing history matching analysis on pressure change and pressure derivative for well tests can be labor intensive. Making a reservoir simulated report at logarithmically distributed time steps, exporting the simulation results to suitable software for analyzing and comparing with the observed data can be complicated. So this plugin allows for a direct comparative to be made between observed pressure data and simulation pressure of a complete test or single build-up or drawdown to see if models are producing realistic results. The plugin was actually developed in conjunction with BG, initially as a software service project, but is now a commercial plugin. So the workflow consists of a mixture of custom-built dialogues and domain objects, but also utilizes native Patrol process. And essentially it allows you to quickly screen and calibrate modeling scenarios to choose the most suitable ones that can be carried forward to simulation. So there's a number of different ways in which these tools can be run to allow various different workflows. So just a typical workflow, so as a reservoir engineer, I want to run a simulated well test for a single build-up or drawdown based on observed production rate and or Sapphire calculated derivative, then compare the results of the simulation with the calculated derivative, or the observed derivative. So the first thing to do is in this particular workflow is to import some production data. So there's basically just a sort of an ASCII loader here. So I pick a well, choose a name, give a date, is it oil or gas, choose the file. So in this case I'm going to bring in time and my gas production rate, which is in column 4. So that gets loaded against the well and can be visualized here in this particular tool, which is determine flow periods. So from that production data, we can sort of graphically represent the particular flow periods that have been imported into the project. So we then come to import pressure change and derivative. So this again is another ASCII loader that allows us to import pressure change and derivative, or in this I'm going to use the example of a deconvolution dataset. But if you weren't importing deconvolution and it was just a pressure change, pressure derivative, you determine which flow period you want to associate it to. You can also choose to use bring in some pseudo pressure conversion, choose which rate type, so is it oil, water or gas. So this in this case gets imported as a deconvolution, a custom domain object. So we have the spreadsheet of the data and a plot of the pressure change and derivative for this particular deconvolution. The next stage is to determine the flow periods and time steps. So we come back to here. So from the production data we've imported, we're going to resample. So you can see it's come in with a sort of regular spacing along the time axis of the sampling in a particular flow period. So what we're going to do is choose to logarithmically resample, say period 22. You can see the sampling displayed here as is now logarithmic. You click apply. This gets saved as a time step object. So it's this particular flow period has been time has been resampled logarithmically and is now stored as this particular time step. That then is fed into the development strategy. So we're going to run a history matching eclipse simulation using the resampled time step as the well rate control. So we can run, generate simulation data logarithmically to tie in with the sampling of the observed data. So you'd set this up, run your simulation, and then finally come to the QC plot. So in this particular example here, I have a particular build-up, a drawdown plotted. So we have pressure change and derivative. And it's then possible to start to overlay the various simulation case results to see which simulation scenario or layering, for example, or what kind of parameters you can change in the modeling grid or the simulation setup to give you the best match between your simulation data and your observed data. It's also possible to calculate the difference between your observed and simulated data. So that was a very quick run through preview of the enhancements that have gone into this well test tool. So I hope that was okay. I know I've kind of overrun slightly, but so the idea was to just give you a run through of the sort of RE and modeling QC workflows available in GDI and some of the additional tools that are currently available in the toolbox. So everything that you've seen is available for free evaluation. All of the tools we've looked at and all of the other Blueback tools are available on the Ocean store, so ocean.slb.com. Obviously, we supply installers, licenses. We can support your demo as evaluation, come and run additional demos. The costs, if you're interested, GDI, so the crossplotter is 18,000 US for 12 months, and the toolbox 8.5. There are very flexible models and discounting models if you kind of combine them together, or take 2 or 3 of each license. The price comes down considerably. If you'd like to find out any further information, please get in contact with us on sales@bluebackreservoir.com. Okay, so I'm just going to see if any questions have come in. Break these out. Okay, so there doesn't seem to be too many questions. We have support for 2012 and 2013 currently. Both of these, all the plugins you've seen, will be supported on 2014 following its release. We kind of upgraded all our plugins within 30 days, I think it is, within the release of 2012. Yeah, the well test tool, this is the version you see, I've just shown you, isn't quite released yet. It's probably going to form part of the next toolbox release, which is due out in kind of 3 or 4 months' time. There is a version of that currently in the Reservoir Engineering Toolbox, if you would like to take a look, but obviously you can see quite a lot more work has gone into this pre-release version you've seen. Okay, so I guess that's it. There don't seem to be any more questions. If you have any questions, please send them through to sales@bluebackreservoir.com. So just to let you know as well, there's a similar webinar being run next week, I guess, based around more geophysical interpretation and analysis workflows in GDI. Again, if you want more information on that, please get in touch. We can send you the links for registration. So that's it. Okay, thank you very much for your participation, and goodbye.